Hi everyone, welcome to the video on gases and pressure units. We're going to just briefly go through this first part, just comparing three states of matter, because really you just have to read this and look over it. There's not a whole lot of practice that we can do with it, but then we're going to look at units of pressure and we're going to practice these. Alright, so we have three states of matter: gas, liquid, and solid. And if we compare each of these, okay, gases are what our focus is in these next series of videos. Gases expand to fill any container. So they're randomly arranged, just organized, and they're very far apart. Because the molecules are very far apart, their density is very low. And they're also moving very fast. Okay, and there's no interaction between these molecules since they're so far apart. For liquids, these have a fixed volume that take a shape of a container, and they are randomly arranged, but they're much closer. So their density is a lot higher. Imagine the molecules are closer, so the density is higher. They move moderately, and they have strong interactions between the particles in a liquid. For solids, these have a definite shape and volume, so they are a fixed arrangement of very close particles. So no matter whether you put a solid, whatever room you put it in, or container, it's going to be the same. It doesn't assume the shape of the container. And these have very high densities and very slow particle movement, and the interactions between the particles and the solid are strong. So here's an example of that. So there you have a solid. Okay, you've got that strong interactions. Liquids also are very close with strong interactions. And then over here on the far right, you have gases that are much farther apart, and there's not the interactions in between them. So a lot more kinetic energy here, and then there's a lot more interaction between the particles with solids and liquids. The kinetic molecular theory of gases, so that's sort of our focus here, is that a gas consists of particles that move randomly and rapidly, and the size of these particles are small. They have no attractive forces between each other, okay, and the kinetic energy increases with increasing temperature. Okay, and if they do collide with each other, if they hit each other, then they will rebound and travel in a new direction. So what's also unique about gases is that they exert a pressure. Okay, and so we have to think about other variables and other things when we do calculations and when we take into account having a gas versus a liquid or a solid. And when gas particles collide with the walls of a container, they exert a pressure. Okay, and so of course this can be dangerous if you have a closed system, or if you heat a closed system, especially never do that, because if gas is evolved, then it'll exert so much pressure that it will be strong enough where it can bust the container that it's in. Pressure is just the force exerted per unit area. So pressure is force over area. But the main thing we want to look at are the units of pressure. So you've probably heard of ATM, so that's atmosphere. And for 1 atmosphere, there are 760 millimeters mercury, 760 torr, 14.7 psi. You may have heard of that unit before. And then 101,325 pascals. Okay, and so in our lab here, we have a barometer that reads the pressure of the room, and it's read in millimeters mercury. And so we have to convert that to ATMs. Okay, and so we're just going to practice converting from one unit to the other. Okay, and then you'll also find as we move through these videos that there are times where our units have to be a certain unit, meaning that we have to use ATMs. Okay, therefore, if you're given millimeters mercury or one of these others, you're going to have to convert to ATMs. Okay, and this is relatively simple. We've done a lot of converting in this course, so really these are just kind of one step, pretty simple conversions. You just have to know, of course, your conversion factors, which are here. All right, so let's practice. So let's pretend that we have 424 millimeters mercury, and we need to convert to ATM. Okay, so if you look back at the previous slide, maybe you've written those down or have them printed, but there's 760 millimeters mercury in every ATM. So we know if we're given millimeters mercury, our units have to cancel, and there's 760 for every one ATM. So if we divide 424 by 760, we get 0.558 ATM. Okay, let's do another one. So let's say we are given 3,000 PSI, and we want to convert to ATM and millimeters mercury. Okay, so let's go to ATM first. Whoops, dropped my pen. Okay, if you look back, if you didn't remember, you have 14.7 PSI in one ATM. So 14.7. So if you divide 3,000 by 14.7, okay, we get 204 ATM. All right, and now we're going to convert to millimeters mercury. Okay, and I also need to be sure my sig figs are good. Okay, and so technically, let's see here, we've got 3,000. Okay, so let's go ahead and make that 204.1. Since we have 4 sig figs, we want to have 4 in our answer. Okay, and now if we convert 3,000 PSI to millimeters mercury, you can go to ATM if you would like and then go to millimeters mercury, or if you just look here, you have 760 torr for every 14.7 PSI, and then look, torr and millimeters mercury are the same, so we're going to millimeters mercury. Okay, so we can do 14.7 PSI for every 760 millimeters mercury. Okay, so when we do the math here, okay, we get 1.55, whoops, there's my 4 sig figs, and then this is to the power of, to the 5th power, millimeters mercury. All right, I hope this helps with converting, and I'll see you soon.